So good morning, students. So today we will start the Lagrange's interpolation formula. Like Newton's forward and backward interpolation formula, this Lagrange's interpolation formula can be used for equally spaced as well as unequally spaced points, whereas Newton's forward and backward interpolation formula can be used only for equally spaced. So let us see proof of this Lagrange's interpolation formula. Let y equal to fx be a continuous and differentiable be a continuous and differentiable n plus 1 times. It is requirement actually for this that the function should be continuous and differentiable n plus 1 times in the interval a, b. Generally, we take a is equal to the initial point and b is equal to the last point. Consider the set of values. Consider the set of values of x and corresponding y as x0, y0, x1, y1, xn, yn. Let ynx be a polynomial in x of degree n and can be written as let me write it to the side. Ynx is equals to a0 x minus x1 x minus x2 x minus xn plus a0 x minus x0 x minus x2 x minus xn. So it is very simple to remember this. If you consider this a0, then x minus x0 is not there and remaining all terms are here. Similarly, when we consider a1, it is just how to remember this polynomial when you write the Lagrange's interpolation proof. Okay, so next term here you can write as x minus x0 x minus now x1, x minus x2 will not be there. So let me write here the next term x minus x3 and x minus xn. In this way, we can write it x minus x0 last term, x minus x1, and now this will be up to x minus xn plus 1, where a0, a1, a2, an are unknown constants. Unknown constants to be determined. So we will use this given data of values of x and y. We can find value of the unknown constants here as, means what are the unknown constants? A0, A1 up to AN. Okay. So same as the Newton's forward and backward interpolation formula, to get values of these constants, unknown constants, A0, A1, A2 up to AN, we will use these points, right? So to get value of A0, we will substitute x is equals to x0. To find value of A1, we will substitute x is equal to x1 and so on. So let us do that. So put x is equals to x0. So at x is equal to x0, value of y, corresponding value of y is y0. So what is value of this? Y0. Y and x at x0 is y0. So therefore y0 is equals to a0. And now here, as it does not contain the term x minus x0, every term is non-zero. So here I will get this term as x0 minus x1, x0 minus x2, up to x0 minus xn. But now next onwards here, each term contains the term x minus x0. So here you will get all the terms 0. So only this term we are getting. So here value of a0 can be determined as, so a0 is equals to y0 upon whole of this whole expression, x0 minus x2, x0 minus xn. This is value of a0. Similarly, we can find value of a1. So for this, we will put, or you can substitute, give number 1 to this, put in 1. Or you can say substitute x is equals to x1 in 1. So at x is equal to x1, value of y is y1. So let us do that. So here it is y1. Now, this first term contains x minus x1. So here you will get term 0. Means this term 0, therefore whole term will be 0. So only we will get this term because x minus x1 is absent in this. And in the rest of the terms, x minus x1 is present. So every term is 0 except a1 term. That is with the term which contains a1. So y1 is equals to a1 into, now here x is equal to x1. So x1 minus x0. x1 minus x2, x1 minus x3, and so on up to x1 minus xn. So value of a1 can be given as y1 upon x1 minus x0, x1 minus x2, x1 minus x3, and so on up to xn minus xn. So now we can guess that what will be the value of remaining constants. So when there is a0, in the numerator we have y0, And in these terms, which is coefficient of A0, x is replaced by x0, which is your denominator. Same way, for value of A1, here the numerator is y1 and the denominator is this expression here, just replacing x by x1 as we are substituting x is equal to x1. So let us generalize it and write down value of an so that we can complete the formula. Similarly, we'll write A2 and then directly we will write AN. A2 can be written as Y2, means value of A2 can be, means we can obtain value of A2 as here. What is coefficient of A2? X minus x0 into x minus x1. So just substitute x is equal to x2. So x2 minus x0, x2 minus x1, then x2 minus x3 because term of x2 will not be there, up to x2 minus xn. X2 minus xn. And then we can generalize for an as, so an is equals to, now corresponding term is yn, value of y is yn. Then here xn minus x0, xn minus x1 and up to xn minus 1. Substitute all these values in equation 1. Let us see what we get. So therefore, substituting values of A0, A1, AN in 1, we get y and x is equals to, now value of A0 is y0 upon whole of this expression. So let me combine this expression, means y0 I will put aside here. This is 1 upon this, and this whole bracket I will write it here, this whole term, so that we can remember. It is easy to remember this formula. So let me write this. What is coefficient of A0? X minus x1, x minus x2 up to x minus xn. Okay. And what is value of now A0? I am substituting. So A0 is y0 upon whole of this expression. So this y0 I will write it here. And here, if you see the similarity, here in the denominator, just replace x by x0 as this term is corresponding to x0, y0 value. So in this, we will just replace this x by x0 and rest of the terms are same. So in this way, we can remember this formula very easily. So here x0 minus x1, x0 minus x2, x0 minus xn and into y0. So this term we can write instead of this, some shortcut we can use when we remember the formula. Next term, substituting value of A1, same way I will rearrange the term, x minus x0, x minus x2 because this is term of y1, so x minus x1 will not be there, up to x minus xn, and here there is y1, and here replace this x by x1 in each bracket, that will be your denominator. So here it is x1 minus x0, x1 minus x2, up to xn x1 minus xn. Similarly, we can write down the nth term as x minus x0, x minus x1, up to x minus xn minus 1. Just write it carefully here, up to x minus xn minus 1, because we are writing the last term which is related to the point xn yn upon now xn minus x0, xn minus x1, up to xn minus 1 into yn. So this is actually the Lagrange's interpolation formula, which is used for any type of values. Either it is equally spaced or it is unequally spaced. And this is very general formula. So using this formula, we can find value of y at any given x, which is not in that tabular values. This is one use. Then secondly, if we have the data in which the values of x are unequally spaced, and if we want to find the equation of the curve or the formula for the for y, then we can find formula for y. Next, one more use of this Lagrange's interpolation formula is, as you people have seen the partial fractions, when we have seen, you people have seen the integrals, then how to integrate the function by using partial fractions. So that partial fractions also we can find using this Lagrange's interpolation formula. So here it doesn't require the data which is equally spaced or not equally spaced. Actually, using Newton's forward as well as backward interpolation formula, if the data is equally spaced, then we can find equation of the curve or formula for the curve, or easily we can find value of y at given x which is not in that tabular values. But this Lagrange's interpolation formula has multi-purposely used, and we can use it very flexibility, using very flexibility to get the desired answer. But again, one more formula is there. There are again some more disadvantages of this Lagrange's interpolation formula. So to overcome this, in the next topic, we will see the Newton's divided difference formula. So let us first complete this Newton's Lagrange's interpolation and the examples related on this Lagrange's interpolation formula. But now, in order to remember this formula, now it is easy to remember, you can remember it, but in order to remember and in order to write it shortly, let us write it, the formula in the form of some Li term. So I will define this term as Li. So define Li. Now when I write Li, the term x minus xi will not be there. Similarly here, that xi minus xi term will not be there, as we are substituting x equal to xi. So just see how we are going to define this Li. So Li is x minus x0, x minus x1, and as in the numerator, the term x minus xi will not be there. Here x minus xi minus 1 and x minus xi plus 1 till x minus xn. So if you are comfortable to remember this type of formula, you use it, you remember it using this way, or you can use this way using this Li1. So now I will put x equal to xi. Here, this is xi and this is x1. Then xi minus 1, xi minus xi plus 1, up to xi minus xn. And then we can rewrite this formula as, so therefore, Lagrange's interpolation formula is yn x. So now this term is related to x0. So I will write here L0. So that I should get here x0. Right here it is, yes. So here, yeah, it is okay. So when I write L0, this x minus x0 will not be there, obviously. So you have to change this according to that. So here it is L0, Y0 plus L1, Y1 plus L2, Y2 up to Ln, Yn. And where Li is this, that is L0 is what? Starting from x minus x0. So obviously x minus x0 and these two terms will not be there that time. So that you have to write. So this is your Lagrange's interpolation formula. In this way you can remember. So let us solve the example on this. Again I am telling you, so it is not necessary that it can be used, it is used only when we have unequal data. You can use it when you have equally spaced as well as unequally spaced. So that is as per your comfort, whether with for equally spaced, whether you want to use Newton's forward or backward or Lagrange's. You can solve this using Lagrange's interpolation formula also. So very simple question we will take it here. Considering unequally spaced data, find example, find value of y at x is equal to 5 using the following data. And the data is here x, y. So here one thing is that we don't need to construct any difference table. Directly from the given data we will pick up the values of x0 and y0. So we need only this table where we have given the values. In forward and backward difference formula, we have to first construct the forward difference table. And then we can use the formula. So now in this table only, by your pencil, you just give the name to this. This is value of x0. Now look at here, this data is not equally spaced. First value is 2. Next value is 4. The difference is 2. Whereas the third value is 7. The difference is 3. So it is not equally spaced data. Let us give the name which we are going to use them as in the formula. Then corresponding value is y0. It is easy to pick up this value if we'll write by pencil the values. Y2. This is y3. Okay. So now as we have only the values up to x3, we will write the formula up to x3, not all the terms up to n. So let us write down Lagrange's interpolation formula. Yx is equals to x minus x1, as I am writing the term related to y. So I am always comfortable to use, remember this formula. So I write it directly. So x minus x1 into x minus x2 into x minus x3 upon now x0, the first term, x0 minus x1, x0 minus x2, x0 minus x3 into y0. So it's just write the formula related to given values only. Okay. No need to write down up to xn. Don't generalize it. Plus. Next term is related to y1. So x minus x0, x minus x1 will not be there. So it is x minus x2, x minus x3. So always three terms will be there. As there are total four values, n plus 1, n equal to 3 here. So therefore we have four values. So always we have three terms of x minus xi in numerator as well as in the denominator. Upon, now we are writing it for x1. So x1 minus x2. As soon as you will write this formula, immediately we can substitute the value and do the calculations. But here you have to do the calculations very carefully. If such type of question is asked, there is no problem to for the calculation. But whenever we want to find the formula for y, so that time the terms are x and the bracket multiplications and the coefficients, collecting the coefficients. So do it properly and stepwise so that no mistake can be committed. Plus next term here, now related to y2. So x minus x0, x minus x1, x minus x3 because x minus x2 will not be there. Let me complete now this formula. And the last term. Y3. So now directly you can substitute and you can evaluate, but I suggest you that to consider this ratio separately, find value of each ratio and then substitute in the formula so that sign mistakes will not be there. Generally you can, means here most common mistake done by you is the sign conventions, because here some negative values, here some positive values. So according to that, you have to check the sign. So better way, consider this term separately and find it first and then substitute in the formula. So let us do as per that. Now we have each value here, value of x0, x1, x2, as well as value of corresponding y's. So let me first consider the coefficients of y0, y1, y2 and y3, and let me calculate it first so that, as I have always means do mistakes in calculations, I do it stepwise. So no chance to commit any mistake, because small error can be, you can lose whole marks. Your small error and small carelessness. So let us consider now here what is x is equal to 5. At 5 we want to find. So first term, let me write it here L0. Now, it is okay. L0 is 5 minus 4. Look, x is equal to 5, x1 is equal to 4. Then 5 minus 7, 5 minus 9 upon, now what is my x0? X0 is 2. So just replace that 5 by 2. 2 minus 4, 2 minus 7, 2 minus 9. Calculate this value. So this is first, so I am calculating it. Put everything in the bracket so that there will not be any mistake while writing the sign, while multiplying the terms having different signs, same signs. Then here it is minus 2, here it is minus 4 upon minus 2, then minus 5 and minus 7. So now here, as per the sign convention, numerator you will get plus sign and in the denominator you will get minus sign. Okay, so whole ratio must have negative sign. So you put first what is the sign of your ratio and then do the calculations with the numbers. Now here if you observe 2 and 2 will get cancelled and only 4 will be there. As for now, don't consider the sign because we have already checked what will be the sign of our ratio. So don't just concentrate on these values. So 2 and 2 will get cancelled, and here 4, and the multiplication is 35. So here value of this L0 is minus 4 upon 35. So that's why it is always better to consider these values separately, because if we'll write the whole terms substituting the values, then we get confused that what we are doing actually. So always do it stepwise. Then L1, let me write that L1. So L1 here 5 minus now x0. x0 is 2. So 5 minus 2, x minus x1 will not be there. So 5 minus x2, that is 7. 5 minus 9. And in the denominator, you have, what is x1? 4. So it is 4 minus 2, 4 minus 7, 4 minus 9. So it is 3 minus 2 minus 4. And here it is 2 minus 3 minus 5. So let us first check the sign of this ratio. Here minus minus, so it will become plus. Here again minus minus, so it will become plus. So sign for this ratio is plus. Put it, though it is plus, you put the sign there. Then now look at here, 2 and 2 will get cancelled. 3 and 3 will get cancelled. So only 4 upon 5. Remaining is only 4 upon 5. So if we'll put it in the example and try to do this, then it will be complicated. It becomes complex. So let me calculate this L2. This L2 is now 5 minus 2, x minus x0. Then x minus x1, that is 5 minus 4, x minus x3. So it is 5 minus 9. And now what is value of x2? 7. So it is 7 minus 2, 7 minus 4, 7 minus 9. So here it is 3, 1 minus 4 upon 5, 3 minus 2. Let us see first the sign again here. So here numerator has minus sign, denominator has one negative sign. So and the division of minus upon minus is plus. So here 3 and 3 will get cancelled, and 2 2s are 2. So it is equals to what will be the answer? Here 2 upon 5. Look at here, 3 will get cancelled. Here 2, if you divide to 4, here it will be 2. So only remaining 2 upon 5, and the sign is positive. So here the sign is positive. So 2 upon 5. Do not make it immediately the decimal. Do not convert it. Put it as it is. Then finally you do it. Well, it will be again problematic to carry these values in the formula. Then L3. So now here we are calculating it related to x3. So 5 minus 2, x is equal to 5. 5 minus 4. 5 minus 7 upon, now x3 equal to 9. 9 minus 2, 9 minus 4, 9 minus 7. Let me write it here. 3, 1, minus 2, and then here 7. All positive. 9 is greater than all these values. Here 5 and 2. So again, check whether the sign of this is minus, because there is sign of numerator is minus and in the denominator there is plus. Now 2 is getting cancelled and we are getting it as 3 upon 35. This 3 and 7 into 5, that is 35. So 3 upon 35. And now we can pick up these values and substitute in the formula. So therefore, yx equal to, let me write value of this L0 is minus 4 upon 35. And what is value of y0? 10. Put everything in the bracket plus. Now L1 is 4 upon 5. And y1, corresponding y1 is 26 plus L2 is 2 upon 5 and y2 is 65 plus last value minus 3 upon 35 into y3, which is 101. And now you can calculate it. I think there is no any problem in calculating this simple expression. Because if we'll put all this in the formula, then we'll get confused and then means some from mistake can be done of that sign. So better we always. So calculate it. And again, the same thing is there, how to verify whether our answer is correct or not. So here at x equals to 5, so where 5 lies? 5 lies between here x1 and x2. So your values, whatever you will get here, value of y should lie between 26 and 65. If it lies between these two values, then you can assume that your value is answer is correct. And if you calculate it, you are getting it nearly equal to 36.97. So you can write it, this is nearly equal to 37. So if you observe here, value 37 lies between, once actually it is at x equal to 5. So it lies between, x equal to 5 lies between x1 and x2. And the value of y we are getting is 37. So you can check it that it lies between the values of y1 and y2, that is 26 and 65.